Welcome everybody to Chapter 9, Section 8, the Law of Cosines. Last time we were here, we did the Law of Sines. We're going to do Law of Cosines. A little more involved, but nothing you guys can't handle. So let's get started with simple definition of what it is. It's a similar thing that we had last time. Last time we talked about, we had an equation that we could solve triangles that weren't right triangles, so we could do any triangle, not just perpendicular, not just right ones. And what it is, this is the law of cosines. Let me write it out for us. It is a squared equals b squared plus c squared minus 2 times b times c times the cosine of a. Okay, that is pretty confusing. Don't worry about memorizing right now, but just let's look at it and see what we have here. I'm going to draw a very simple triangle for us to examine and figure out what we are talking about. So we have capitals for the corners and lowercase for the sides. What we are talking about here is when we have four pieces of information. When we have, and these are repeated, those are the same ones. And this. So we have this side, this side, this side, and this angle. We actually don't have all four of those. We have three of those four, and we're looking for a fourth. We have three of those four. We want 3 out of those 4 in order to find the fourth one. So if I have two sides and an angle, I can find the other side. If I have two sides and an angle, I can find the other side. If I have 3 sides, I can find an angle. If I have 3 sides, I can find an angle. A, B, and C are not locked in. The way to think about it is this term right here is opposite our desired angle. So that is the one opposite our desired angle, while these two, B and C, are next to the desired angle. They're next to the desired angle. So don't think of them exactly as A, B, and C and looking for those letters. What we're really doing is we have desired angle we're looking for maybe, or the one we have, and then A is across from it and B and C are next to it. Like everything in math, especially at this level, let's jump into one and see if that makes more sense. And I will rewrite the law of cosines on our problem. So if you need to slow down the video, go back, copy something down, please do so. That is the beauty of online notes. We have this angle, we're going to be looking for x. Keep in mind, this is not just for right angles. This does work with right angles, but we have easier ways to do it if we have a right angle. A squared equals b squared plus c squared minus 2bc cosine a. That's just the law of cosines. That'll be available to you on either a formula sheet, on a board, on the problem itself. So here we are. Well, let's identify our four pieces. We have x right here. We have 2.9, which is this side, 0.9, which is that side, and this angle, 44. Well, we know this is our A. That's our only angle. So that is going to go in here. I'm going to rewrite it just so I can sort of visualize it with what I have in this one. Cosine 44. Well, what are B and C? B and C, hopefully you're figuring this out, are the ones flanking the angle, the ones next to surrounding the angle. So our B and C in this case are going to be 2.9 and 0.9. It does not matter which one you make B and which one you make C. They are interchangeable, like henchmen in a James Bond movie. So I'm going to make B 2.9 just because, and C 0.9. So let me work backwards now. 0.9, that's my C, 2.9, and 2, that's this term, 0.9 squared plus 2.9 squared. Writing backwards is very difficult. So that means this x is my a squared. Or is my a. So x squared is my a squared. That is very important to remember that it's actually a squared. You're going to square this side. If you can start to see what we have here, this is the easiest version of the problem. Look at it for a moment, see if you can figure out why. The easiest version of the problem is going to have all of our numbers on one side and our variable over here. If this x is hidden inside here, we have to do some work. We have to do a little bit of stuff to get it loose. We will do one of those. It's a little bit of work, but I want you to start with this. All right, so this is the easiest problem because if you look over here, this is all just numbers. Complex numbers, difficult, there's decimals and multiplications. Here, let me even clear this up. There are some multiplications in here and some decimals. I'll change it to that. There you go. Now you can see what's being multiplied. I'm just going to put this entire thing in my calculator. You could do pieces of it and then do it from there, but I paid $100 for this calculator. Hopefully you did too, so I'm going to get my money's worth. So let me put 2.9 squared, 0.9 squared, minus 2 times 2.9 times 0.9 times cosine 44. Remember, we're using the cosine and other trigonometric functions. Make sure your calculator is in degrees. We do that every time. Every video I kind of show you how to do it. You go to mode and double check that. If you're not, you're going to get a strange answer. So when I plug that in, I should get x squared, I didn't touch that side, equals 5.4650. I'm not done, that's why I'm going to keep some decimals. I'm still working. I don't need them when I'm getting my final answer. And then I just square root both sides, and I get x is equal to about 2.3. Now, does that seem like a reasonable number? We'll come back up here, 2.9, 09, 2.3. Yeah, that seems really good. And so that is the law of cosines being put into practice. That is the law of cosines being put into practice. We have our big long equation. This is the easiest version where we have all of our pieces on this one side. We can kind of clean it up that way. Okay. So what do we do? We'll hold off on the hardest kind. Let's just kind of stick with the two base models. There's that one to find a side, and then let's jump to one where we're finding an angle. So we'll hold off on the very complex one for right now, just because I want to kind of lay the foundation. And so we have a very similar problem where we're looking for the angle. Let me write out our formula again. That way we have it. Law of cosines is a squared equals b squared plus c squared minus 2 times b times c times cosine of a. Notice these are different a's. Capital A is an angle, lowercase is a side. I don't have my angle. So my missing piece is going to go right there. That's my missing piece. That's my x. Well, it does not matter which one is b and c, but it does matter which kind of ones I pick. Remember, b and c are the ones touching the angle. So these have to be b and c, which makes this have to be a. That's a 9. Looks like an A. I wish it didn't, sorry. For this case, I'm going to make 11B. And 5c. That just makes sense in my brain. So let me take all the pieces I have and put them in. 9 squared equals 11 squared plus 5 squared minus 2 times 5 times 11 times the cosine of x. Okay, not totally simplified. There's still some pieces that need to be fixed. So let me do that. Well, I can do some easy ones. I can do 81. For example, 9 squared, 81, equals, I'm actually going to put these two together, and I'm going to put these two together. The reason I can't do all of this together is because this is a term. If you remember that from back in algebra, that is like a term because of that variable is locked onto there, and it can't play with just numbers. So 11 squared plus 5 squared is 146. Minus 2 times 5 times 11, 2 times 5 times 11 is 110 times cosine x. So they are different terms because that cosine x, it's being multiplied, so it's kind of latched onto here. This one doesn't have anything being multiplied, any variables being multiplied to it, so they're kind of free to just come together. But these are all latched together. Now, this does not become, I'll do it in red, that's like the classic prohibitive color. It does not become 81 equals 36 cosine x. I'm not going to subtract them. Don't do this. What's going to happen is I have to move this over here. I have to get rid of that so my x is by itself. You see this x is just kind of, there's a lot of stuff that has to move away until this x is by itself because we need x equals something to get an answer. So I'm going to move this 146 over there. It's going to be negative for just a moment. That is okay. We will solve it in a moment. Negative 65 equals negative 110 times cosine x. The reason it's negative 110 is because it was still negative here. That didn't go anywhere. We just moved the 146. We actually prefer that it's negative 110 because when I divide, we're going to have two negatives, and then we have a positive. I'm going to swap these sides. So cosine x is over here equals 65 over 110 is 0.5909. All right, let's take a moment just to review the algebra. Because nothing we did here was actually new. All this stuff was just algebra with a cosine function in there. Like we didn't touch it yet. We had our law of cosines. I could combine this into 146, and I could put the 2, the 5, and the 11 into 110, but I couldn't put them together because this had a additional piece to it. This had this cosine x, which doesn't mix with regular numbers. So I had this. So my next step would be to move the number. I subtracted 146 to get negative 65 is this. Divide the 110 away, so I'm just left with cosine x is this. And that's just from putting that in my calculator. You should know what to do from here. This should be very straightforward from the stuff we have done. And you see, this is a decimal. While I'm working, I'm going to keep as many decimals as I can. My final answer, though, I'm going to do just one decimal. All I have to do is look up this number on my cosine chart and see if I can find the closest angle to it. Or, if you do have a calculator, which I hope you do, you're going to do the inverse cosine. That's the same as look up this number on your chart. So I'm going to look up on the table what angle gets me closest to that cosine. Is it going to be exact? I would guess not, just because it's so hard to have perfect numbers always work out to be exact, but I could be wrong. And on my calculator, I got 53 53.77. I'm going to do 53.8. On your table, you might see 53.5, maybe somewhere between 53.5 or 54. If you have the table, you don't know it's 0.8. You have to do something like 0.5 or the whole number. Those are your options. But any of those, I am perfectly happy to accept. So that's a little harder. But you can see it's the same idea. It's the same little formula. You're not memorizing the formula. I'm sure there are times when you should memorize formulas, but for me right now, using the formula is the hard part. This one is very tricky. This step right here, people love to do this. Please don't do that. That's going to get you a wrong answer. Remember this. This will always be our pattern, how we do it. And we can find a missing angle given 3 sides. The first one we did, we had 2 sides and an angle. We were finding a side. This time, we are finding a missing angle. Okay, let's do one final one all together, and then we will call it a lesson. We are going to do what's called solve the triangle. If you don't know what solve the triangle means, what it is we're just going to find everything. In this case, we're finding 3 angles. 3 angles. In other cases, we were finding 2 angles. Or in another case, we were just finding one thing. Solve the triangles means show that we have everything. Okay. It's going to be a little challenging, but we're going to go through it. Let me write out our law of cosines. We're still using that. And we actually can, at some points, use the law of sines. I'll show you that in a moment. So keep that in your brain. We will be able to bring that in just a moment. Times cosine of A. Now we have to find our first angle. And really there's no easy starting choice. They're all going to be about the same difficulty. I'm going to choose to find this angle right here. You don't have to. You can start at a different place, and that's the great thing about this kind of problem. You can have different starting points, 3 different starting points, and get the same location. All right, so let's start with 8 and as my a squared. And so we have a squared. I'm going to make this b squared and this c squared. So I'm going to make this 8 squared equals 14 squared. One second. 14 squared plus 20 squared minus 2 times 14 times 20 times the cosine of, I'll just call it A. I will leave it as A. So all I'm doing is filling this out. I have 64 equals 14 squared plus 20 squared, 596. Minus 2 times 14 times 20, 560 cosine A. Okay, so I'm finding this. Do not put these together. I know you want to, but this is linked to this, and so that those can't play together. 596 minus 596 minus 596 is negative 532 equals negative 560 times cosine A. Okay, divide by negative 560, divide by negative 560. Cosine A is equal to 532 divided by 560, 0.95. I don't know if that is on the sheet. Once again, I don't have my sheet with me, but I have my calculator. I'm going to look it up, do my reverse search. Second cosine 0.95. So our angle A is equal to the inverse cosine of 0.95. And that is around 18.2 degrees. So we'll say 18.2. That's probably not exact. We cut off decimals. And let me see if I can get... let me see if I can... I'll keep it 18.2. I probably should just round to 18, but I'm going to leave it there. So I have a couple options now. I can do another law of cosine, just change 8, 14, and 20. Or I can use my law of sine. If you remember, law of sine was the sine of one angle over that side equals the sine of the other angle over that side. And I have enough pieces here to find something. I actually only have to do one more kind of mathy step. The third angle, once I get that second angle, I can just find out what it is from 180. So I only have one more angle I have to solve for. I'm going to pick this one for no reason. So I'll call this A. I'm going to call this B. So the sine of A, the sine of 18.2 over 8, because remember in law of sine, that's a little recap, these opposite ones are connected. Sine of that. So that means B has to be connected to 14. The sine of B is 14. Okay, if you remember how to do these, there's a couple different ways we can focus on it. I'm going to just turn this into a number over here. There are other times we cross-multiplied. There's no exact way you have to do it. As long as you're solving your ratio and keeping track of all your pieces, you should be okay. So we have this equals the sine of B over 14. So let me show you again what we're doing. On this one, this is all to find this angle, and then this one was all to find that angle. Then the last angle will be the easiest one to find, times 14 times, second answer, 0.5465 is the sine of B, and I have to do a reverse lookup. I have to look on my table and see what decimal on the sine column is close-ish to this. If you can't tell, if you are using your calculator versus your table, you're going to have kind of different numbers. They're not going to be wildly off. They're only going to be about 1 or 2 degrees off, but it shouldn't really change the scale of your answer. And for B, I get something around, with the decimals, 33.1 degrees. 33.1 degrees. So all I have to do for my last one, I have 2 of them. My last angle is going to be whatever gets to 180. (180) minus 33.1 minus 18.2. And so C should be somewhere in the ballpark of 128.7. Okay, so that is an example using all the pieces. It's using some law of cosine, it's using some law of sine to do things. It is possible to check your work. It's not super straightforward to leave it on the other side, but this is the kind of problem you can see. This is the kind of problem I'm going to put on the test just because it gives you a lot of things you should be able to do. You don't need to memorize these laws. These are things that if they're in front of you, you should be able to use them at any moment. So don't spend your energy memorizing them. I hope That's never something you spend a lot of time doing in this class, but I hope you know how to use them. How to find angles or sides of a given triangle when you have certain pieces of information. Well, great. I hope this was helpful. I hope you understood what was going on. And I will be making a review video soon of all the trigonometry we have done. Thank you.